Alright, dear children, now we discuss in detail about a curve isothermal curve. Okay, now in the last YouTube video you learned in detail about what is isothermal process, and in that process you learned that for ideal gas as a system it follow exactly what law? Boyle's law. Means Boyle's law follow means PB is what? Constant. So when pressure and volume, product of pressure and volume remain constant means PB is constant, means I can write that P is equals to constant by volume, and from here you can see that P is inversely proportional to B. Means when volume increases, pressure decreases, or when volume decreases, pressure increases, and vice versa. But this is true at what? Constant temperature. At constant what? Temperature. So this is actually called what law? Boyle's law. And exactly for ideal gas as a system, okay, on the isothermal process, follow what law? Boyle's law. That's why we need to draw a graph between the pressure, as pressure is symbolized by P, and volume, which is symbolized by the B, of a given mass of ideal gas, basically a gas called ideal gas as a system at constant temperature, and this graph is actually called as isothermal curve. So children, remember this, what is isothermal curve? It is a graph plotted between pressure and volume of a given mass of a gas at constant temperature. And this curve is called isothermal curve. And this isothermal curve will be plotted as follows. And children, the graph, as I said, has to be plotted between pressure and volume. So I have taken pressure along y-axis and volume along x-axis. This is P versus B graph. Okay, to express what curve? Isothermal curve. And the nature of the graph will be exactly like this, a non-linear graph. The graph nature will go like this. And this is called non-linear graph, also called as hyperbolic graph. Okay, and this graph which is plotted at a constant temperature. At a constant what? Temperature. And I consider this that temperature, say T. So you can see this graph saying that when volume increases, pressure decreases. When volume further increases, pressure decreases, but it decreases non-linearly. Means when volume increases, pressure decreases, but non-linearly. That's why the graph is a non-linear graph, like a curved graph. That's why this graph is also called isothermal curve. But this isothermal curve graph between pressure and volume can be plotted for different temperature. I mean, this is at one particular temperature. So when you increase the temperature and make that temperature constant, and again you plot the graph, your graph nature will be same. Okay, but the most important part from this graph that we need to calculate is the slope. We need to calculate the what? Slope. Now to calculate the slope of the graph, so let me just start with this relation. As you know, PB is constant. Okay, let me write that constant and say K. Okay, let me write the constant as what? K. Now, in order to plot a graph, calculate the slope from this graph, so what I do, I differentiate this equation. So let me just write down again, PB is equals to K, and I give this as equation 1. Now, I do differentiate. Children, I do differentiate equation 1 both sides. So I write down differentiating. Okay, differentiating equation 1 both sides. Okay, so if you differentiate both sides of equation 1, so on the left hand side P and B both are variable, where K on the right hand side is constant. And when you differentiate, okay, we follow this differentiation. First variable, P is the first variable which is variable, differentiation of second variable, that is called dB, plus second variable and the differentiation of first variable. So this is the formula. When there are product of two variable, okay, then differentiation is given by first variable, differentiation of second, plus second variable, differentiation of what? First. Okay, equals to, now differentiation of constant is always 0. Children, remember this, differentiation of this constant is always 0. Any constant, differentiation constant is always 0. Whereas differentiation of the product on the left hand side is always given by this. Okay, now what I do, I'll make this as a subject. I'll make this as a subject. So I write on B dP equals to, now P dB I'll take in the right hand side, you know, it will be minus P dB. Okay, now this dB I'll bring in the left hand side. So dP by dB I'll bring in the left hand side. I'll denote the left hand side equals to minus P by what? B. So children, look at the expression. dp by db equals to minus p by b. This b will go in the denominator. Now this dp means the change in y-axis and db means the change in x-axis. And children, for your information, change in y-axis by change in x-axis actually measure the slope. So remember this part. The slope is always measured by change in y-axis by change in x-axis. And children, you have learned in class 10 also, maybe you have learned in class 10 also one of the chapter called straight line. And the slope of straight line is given by tan, say, of theta. And tan theta equals to perpendicular by what? Base. So if you look at this graph and you need to calculate the slope from this graph, okay, so we can simply draw a line from any point. If it is a curved line, then you can draw a line this way. Okay, you can simply draw a curved line this way and make a slope. So to calculate the slope, it form a right angle triangle. With that, we find the change in y-axis. Change in y-axis by change in x-axis. Change in y-axis means perpendicular. This is the perpendicular of this right angle triangle. And change in x-axis means base of this right angle triangle. Okay, so in this way also we can calculate the slope. But remember this part, change of slope is always given by change in y-axis by change in x-axis. And change in y-axis means delta P. Delta P, a very, very small change of pressure. And change in x-axis means delta B, where very small change is what? Volume. So that means this is a slope. So I write down this is a what? Slope. And this slope is for what? Isothermal process. So children, you can see now dp by db equals to minus p by b is the slope. This is the slope of what process? Isothermal process. And from this slope, we can clearly see that the slope of isothermal process is negative and it is given by minus p by b. So the ratio, the value of p by b with negative sign measure the slope of isothermal process. And children, you can understand even that with this negative sign that when volume increases, pressure decreases. When volume increases, pressure decreases. Okay, so that the ratio is always measured by the factor that is PB, dP by dB, and this dP by dB is actually the slope of isothermal process. But negative signs say that when one quantity increases, another quantity decreases. Okay, that's why the slope of isothermal curve is always negative and is always measured as minus P by B. Okay, so this is the explanation of isothermal curve. Now we have next process to discuss in detail, that is called adiabatic process, and that you learn in the next YouTube video.